In this video, we're going to talk about ballastic pendulum. So ballastic pendulum is under linear momentum. So what we have to understand is that ballastic pendulum, it can either elastic or inelastic collision. So I've got a question here. This question is from one of the exam past papers, which is saying a 0.03 bullet is fired vertically at 200 meters per second into a 0.15 kg cricket ball that is initially at rest. How high does the combination raise after collision, assuming the bullet embeds itself in the ball? Okay, so let's have the pendulum. So here is my pendulum. Okay, I have my pendulum here. So now we have the ball. The ball, I'm going to put this one as the ball. Then I have the bullet. So this is the bullet. So after collision, the bullet has to penetrate the the ball. So what we're going to have there is going to be raised somewhere here. So we're going to have something like this. Then the 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 gun now, or the bullet now, is inside the what? Is inside the ball. So this is the bullet, and this is the cricket ball. Now we can clearly see that it has moved from this point all the way to that point. Now we are going to call this as our h, that is the height, how high it has moved. Now we are trying to find the the height. Okay, but remember, we have been given the velocity of the bullet. So the velocity of the bullet, we have been told that it is 200 meters per second, but the velocity of the ball, it is basically 0. So we also have the mass. So allow me, I'm going to say, let the mass of the ball, or of the bullet, to be mb, and the mass of the ball to be, I'm going to say m. I can even say capital B. Okay, then what I'm going to have now from my data, I can clearly see that I'll have my mb to be 0.03 kgs. This is the mass, which is here. Then my m capital B, which is for the ball, we can clearly see that it is 0.15 kgs. What else do we have? We have the velocity of the bullet, which is initially 200 meters per second, but we also do have the velocity of the ball, which is initially 0. Now after collision, what happens? Now we can clearly see that this is inelastic collision, where after the collision, the bullet and the ball, they are moving with the same velocity. So what is the formula for inelastic collision? We know that the formula for inelastic collision is, I'm going to say mb vb initial plus the mass of the ball, the velocity of the ball initially, is equal to, since it is inelastic, meaning that they are moving with the same velocity, so it's going to be, we have to add these two masses, then you have to say the final velocity. If this was elastic collision, then you have to use the formula for elastic collision. So ballastic pendulum, it can either be elastic or inelastic collision. So it just depends with the question. Okay? Now, if maybe it was elastic collision, then we'll have to say, you have to use this formula. If it was elastic collision, so you have to use this. Then you say mb vb final plus m capital B v capital B final. So you can use this for elastic collision. Now because this is elastic, I'll use this. Okay, but before we continue, what you have to understand is that you can access all the past paper question videos which we have just solved. um, Let me show you how you can access them. So if you want to access our videos from Transcended, just go to Chrome, okay, and search Transcended Institute. So you'll be able to see all the videos which you have. So this is our website. If you want to access the videos for math, physics, biology, then you have biochemistry for second year, then math 2110 for second year, and chemistry. So let's assume to say you want to access the videos for biology. Then you go there, you just click on biology. You can see that we have all the topics here. We have water, eukaryotic cells, prokaryotic cells. We have all the topics: DNA replication, transcription, nucleic acid, translation. So let's say you want to watch the videos, or you want to access the videos for DNA replication. You just click there. You see that we have all the content here. Okay, and these videos you can't find them on our YouTube channel. Okay, so these videos can only be accessed by the student who are registered with Transcended Institute. Okay, I can also show you the videos which are there on YouTube, the ones which you can't watch. Okay, so you can watch. We also have some videos, the membership ones. If you want to access them, you can register with us. So now if you go on our YouTube, you just type Transcended Institute, you'll be able to see this. So now, so if I go on membership, I can clearly see that we have these videos. There's chemical kinetics tutorial sheet, which is 3 hours 33 minutes. You can only access a 1 hour video for chemical kinetics. If you want to access the full video, it's there. Now we also have conical pendulum. We have the past papers for biology. Okay, then you have also biology, meiosis, then circular motion past papers. We have rotation, work energy, and momentum past papers, genetics past papers, then chemists lab test preparations, linear motion, free fall, and projectile motion past papers. So yeah, we have static equilibrium past papers, we have Newton's laws of motion past papers, and tutorial sheets. So if you want to access these videos, all what you have to do is you have to register with Transcended Institute. Now, how can you register with Transcended Institute? Now, what you can do is you can get in touch with the admin, or you can get in touch with me using this number: zero plus six plus 26076772 9927. You can either call this number or text this number on WhatsApp. Okay, if you want to register, it's only 100 kwacha per course per month. Okay, so there we go. Let's continue. Now, I'm trying to find the height. Okay, I can clearly see that the formula which I'm going to use is the one for inelastic collision. So the one for inelastic collision we have there. Now I can plug in the values. I know that initially the ball, the velocity is 0, so I can cancel this. So my final formula will be mb bb initial is equal to mb plus m capital B velocity final. Now let's try to plug in the values. So if I'm to plug in the values here, let's see what we're going to have. What is our mb? Our mb is 0.03 times the velocity is 200. This has to be equal to the mb is 0.03 plus the mass of the ball is 0.15, then the final velocity. Remember, I'm just finding this final velocity so that I'm going to use work energy theorem, where I'm going to say when this guy was moving, when these two guys were moving from this point going up, initially they had kinetic energy. So this kinetic energy, now it is on top. So the kinetic energy will be equal to potential energy. So I'll have half mv squared is equal to mgh. So this h is the one we are trying to find, but we are not interested. We can see that we have got mass both sides. I can cancel mass, so I'll have half v final squared is equal to gh. Now I can use this formula to find the h. Now this v which I'm going to find here is the one which is our velocity there. So let's go ahead and first find the v, and then we go ahead and find the h using that formula now. So what I'm going to do now is I'm going to say 0.03 times a 200, which is 6. Then I also have 0.03 plus 0.15, which is giving me 0.18 v final. I can divide both sides by 0.18, even here by 0.18. So our v final will be 6 divided by 0.18, which is 33.33 meters per second. Now using that other formula, using this formula now, so that is my final velocity. Now we know that when it was down here, it had kinetic energy. As it was going up due to height, then the kinetic energy was being converted to potential energy. So that's why I've said kinetic energy is equal to potential energy. Then I need to make h as a subject of formula. Then I need to find the what? The h. Okay. So now I'll have half v squared gh. I can divide both sides by g, even here by g. H will be equal to half v squared divided by g. Let's go ahead and plug in the values. We see what we're going to have. So I have h is equal to half. My v is 33.33 squared divided by 9.8. So our h will be 33.33 times 0.5, because 1 over 2 is 0.5. So I'm getting 16.665. I divide this by 9.8. So how high it was 1.7 meters. Now sometimes they can give you this h, okay, then they are going to ask you to find the velocity of the bullet. Okay, so to find the velocity of the bullet given the h, what you have to do is you have first to start from kinetic energy is equal to potential energy. Now after this you are going to find the velocity. Now this velocity is going to be the velocity after collision. So from our formula we said mb vb initial plus, initially this was at 0, so it's going to be equal to, from this. So the velocity which you are going to find here, since you're going to have the h in case they are going to ask you to find the velocity of the bullet, so you have first to find the h. The h is going to be given, so you have first to find the velocity. Now that velocity is the same as the velocity which is going to be there, so you are going to plug in the velocity there and then find now the what? The velocity of the bullet. So this question they can ask in two parts. They can either give you the h, the height, then they ask you to find the velocity of the bullet, or the way it is, they are going to give you the velocity of the bullet, then they ask you to find the height, meaning you have to use this formula like the way we have done it. You have to find the final velocity, you go back to that and plug in the values and find the h. But if they've given you h, you start from there, then you go like that. So that is it for ballastic pendulum. Now in a case where you have been given elastic collision. You use the same formula for elastic collision. So if they ask you to find the velocity of the ball after collision, then you use the same formula to find the velocity.